Hey guys, welcome back. Lesson is for Friday, May 1st. Yesterday we talked about multiplying rational expressions, and as is usually the case, the next step is dividing. So today we're going to be on a lesson point four, lesson point four, 11.4, and we're going to deal with dividing rational expressions, okay? So if you don't have your book open, open it to page number 418, lesson 11.4, dividing rational expressions, okay? That's what we're going to be for today. So, if you understood multiplying rational expressions, then we shouldn't really have much problems with today's lesson because dividing is pretty much multiplying with one extra step. All right. So let's just jump right into this. We're on page 418, lesson 11.4, dividing rational expressions. And we're going to start off here with our steps, okay? So let's take a look at the steps or the process for dividing rational expressions. Now we know when dividing fractions, our first step in division of fractions is to invert, okay? We're going to invert and basically, just like we would in regular fractions, our step one for dividing rational expressions is going to be, whoops, I don't know what I did there. Let's clear that. I think I moved my canvas around. Okay, so step number one is invert. All right, so we're going to take that second fraction and we're going to flip it upside down. All right, just like we would do with regular fractions. Okay, step number two, just like we do in regular fractions, we are going to multiply. Okay, and basically we're performing the process of multiplication like we did in lesson 11.3. Okay, so what were our steps for the multiplication process? Okay, number one, we factored. Okay, we're going to do the same thing. We invert our second fraction, and then we look at all of our numerators, all of our denominators, and we factor them. Okay, step number two was to cancel. All right, so we went through and we looked at all of our common factors, and we canceled all our common factors out. Step number three was to multiply. Okay, we multiplied all of our numerators together, all of our denominators together, and then we set the canceled factors to equal 0. Okay, so we'll do that same thing, and then our last step was to write the excluded values. Okay, so the steps for division are the same exact way as multiplication. The only difference is we have to invert our second fraction before we can do our multiplication process. So remember, when we invert that fraction, what we're doing is we're changing our division over to multiplication, okay, by inverting that fraction. So we're going to do the same process with all of our division here. So let's look below here. Actually, let's go ahead and do 11.4, exercise 11.4, so that you can see, or example 11.4, excuse me. So we've got 5a cubed b over c divided by 4a over c. Okay, now we're going to take this the second fraction, and we're going to invert it. So we've got 5a cubed b over c times c over 4a. Okay, so we've inverted. So our first step is to factor. Okay, if there's anything to factor, then we factor. In this case, there's really not. Okay, so we're just going to do our canceling. This a cancels out one of these a's, so I got a squared, and this c cancels out this c. So I'm left with 5a squared b over 4. Okay, so I write this as, again, I'm multiplying across, so there's nothing to multiply except for 1 here. Okay, so I would be multiplying this across. So 5a squared b over 4. All right, so this would be the answer for my fractions. Now, just like in multiplication, we have to set those canceled terms to 0. Okay, so I canceled out C's. All right, so first of all, let's start with A's. I canceled out an A. Okay, so A equals 0, and then I canceled out a C. So C equals 0. All right, my answer then, my final answer is 5a squared b over 4, where a does not equal 0 and c does not equal 0. All right, that is the basic process of dividing rational expressions. Okay, now look at the bottom of the page here, page 418, below the first example there. It says, notice in the previous example that the value of a was excluded from the final expression, right? The variable value must be excluded if it makes any fraction have a 0 denominator at any point in the problem. Okay, so they excluded a because it was in the denominator when we inverted it. Okay, so we're including that because even though that was a numerator and before we inverted it, now it's a denominator, so we have to exclude that from there. Okay, and again, that's because it does not appear in the final answer, in the denominator of your final answer, just like we dealt with in our multiplication. Okay, let's look at another one. All right. Let's look at example B. Just like before, they get a little more complex as we go through here. So I've got x squared minus 9 over x plus 1 divided by x squared plus 4x plus 3 over 2x minus 6. So my first step again is to invert. So I've got x squared minus 9 over x plus 1 times 2x minus 6 over x squared plus 4x plus 3. Okay, so now that I've inverted, now I'm just following my steps for multiplication. So my next step in multiplication would be to factor. Okay, so here we invert. That's step number 1. And then step number 2 is to factor. So let's factor these. X squared minus 9. What does x squared minus 9 factor to? We've got x plus 3 and times x minus 3 over x plus 1. Okay, and then 2x minus 6, we can factor the 2 out, leaving us x minus 3. And then x squared plus 4x plus 3 factors to x plus 1 times x plus 3. Okay, so step number 2 is to factor. All right, so we factor out all of our numerators and all of our denominators until there's nothing left to factor. Okay, step number 3 is to cancel. Okay, so what do I have that can cancel out here? I've got an x plus 3 here and an x plus 3 here. And let's see. X plus 3, x plus 3. Is that all I can factor out? I thought there was more to factor out here. No, I think that is all. Yep, that's it. Okay, so I've canceled everything I can cancel. And now step number 4, I do my multiplication or multiply. Okay, so this cancels out and this cancels out. So I've got 2 times x minus 3 times x minus 3. Okay, and then I've got over x plus 1 times x plus 1. Okay, now, because these here are the same, they're perfect squares, we're going to write them as 2x minus 3 squared over x plus 1 squared. Okay, so this then would be our answer. All right, and then of course we would multiply, or not multiply, not we are going to set to 0 here. Give me just a second. Okay, sorry about that. I had to take care of something real quick. I've done my multiplication. Now I'm doing my setting to 0. So I take my canceled term. Now here I have x plus 3 equals 0. So x equals negative 3. Now I want to point something out, okay? Here we have 2 times x minus 3. Now this term right here was originally in the denominator before we flipped it, okay? So remember, we had inverted this, okay, where this would have been the denominator and this would have been the numerator. But since this was at some point in the denominator and is no longer in the denominator and is not present in our final answer, I must also exclude this from my domain, okay? Now again, let me repeat that. We originally had this fraction, okay, where our 2x was in the denominator. We inverted it so that now it's in the numerator and no longer in the denominator. But at some point, this was in the denominator. It was a denominator. So because it is no longer a denominator and it is not found in our final answer, I must also exclude x minus 3, okay? So hopefully you understood that, okay? So I have to look at what my original denominator was, okay? And then if that denominator, or that original denominator, is not in our final answer, then I have to also exclude that from my domain. So then my answer would be 2 times x minus 3 squared over x plus 1 squared, where x does not equal negative 3 and 3, okay? Again, let me explain this, okay? Before we inverted our fraction, okay? Before we inverted our fraction, all right? This here was our denominator. It was our original denominator, okay? We inverted it. Now remember, anything that was in our original denominator, or anything that's in our denominator that's excluded has to be, or excuse me, that's canceled has to be excluded at the end, all right? So this was our original denominator. Even though it is no longer in the denominator, if this is not present in our final answer, okay, x minus 3, if x minus 3 is not present in the denominator of our final answer, then this must also be excluded, okay? And I'm sure we'll come across another instance of that, but I just want to nail that down. Okay, so that's why we have this right here, x minus 3 equals 0, because x minus 3 was originally in the denominator and is no longer in the denominator in my answer, okay? So we'll come across another one of those, I'm sure, and we'll get some practice on that. Okay, so let's look at another one here. All right, so we're at 11.4c. Okay, so I've got x squared plus 5x plus 6 over x squared plus 4x plus 4 times 2x minus 3 over x squared minus 9 divided by 2x squared plus 7x minus 15 over x squared minus x minus 6. Now notice the difference here. We have a multiplication already going on and then a division, okay? This is no different than anything else. You still take the second fraction here and invert it, okay? So we're going to rewrite this as x squared plus 5x plus 6 over x squared plus 4x plus 4. This stays the same, 2x minus 3 over x squared minus 9. This inverts, x squared minus x minus 6 over 2x squared plus 7x minus 5, okay? So we invert our second answer, or second factor our second fraction, excuse me, in the problem. Okay, so now everything's in multiplication. Now I can factor everything out. Okay, so I take my first one here, x squared plus 5x plus 6 factors to x plus 2 times x plus 3 over x plus 2 times x plus 2. Okay, that's our first one. Then we look at our second one, 2x minus 3, there's nothing to factor there. Okay, over x plus 3 and x minus 3. Okay, and then x plus 2 over x minus 3 over 2x minus 3 and x plus 5. Okay, so we're factoring all these here. Each numerator, each denominator, we factored if it can be factored. Now we're going to go through and do our canceling. Okay, so we've got x plus 2, x plus 2. We've got an x plus 2 and an x plus 2, x plus 3 and an x plus 3. I've got a 2x minus 3 and a 2x minus 3, an x minus 3 and an x minus 3. Okay, so everything has been canceled out that can be canceled out, leaving me with 1 over x plus 5. Okay, and remember this is in the denominator, so it still has to stay in the denominator. Okay, we can't just put x plus 5. It's x plus 5, 1 divided by x plus 5. Okay, so we've got 1 over x plus 5. Now I have to take my excluded values, find my excluded values. So I start with x plus 2. Then I've got x plus 3. I've got x minus 3 here. So x plus 2, x plus 3, plus 3, x minus 3. I already did x plus 2. And then 2x minus 3. Okay, so those are all my canceled values are represented here. Okay, so I solve for x in all of these. -2, -3, +3, 2x, 3x is 3 over 2. Okay, so here's all my excluded values. I have to include this in my answer. Okay, so now my answer is 1 over x plus 5, where x does not equal -2, -3, 3, and 3 over 2. Okay, so that's how we do that. Again, don't let the looks of these intimidate you. Okay, just follow your procedural steps, and it shouldn't be too complicated if we can just continue to follow those as we're working through them. Okay, so that is division. The division is really no different than multiplication, except that we have to remember, number one, we invert. Okay, number two, remember when we're finding our excluded values, if it was previously in the denominator and is no longer in the denominator in our answer, that has also been excluded. Okay, so we have to include that in our excluded values. Okay, so if you have any questions on that, or that just didn't come out right, you don't understand it, you need it re-explained, just let me know, and I'll get with you, and we can even do a video conference if we need to explain this a little further. But just follow your basic division rules there in order to complete the division of rational expressions. Okay, now your homework for today, practice 11.4. The first 1 through 8, we're just writing the reciprocal. I think that we all know how to write the reciprocal, so I'm not too worried about that. But let's look at 9 through 28. And let's just go straight down the right side there, or excuse me, the left side, and do 9, 17, 21, 23, and 25, okay, of your blue tabs. All right, we're on page 420. we're in the division section here at the practice problems, and go 9, 17, 21, 23, and 25. So that'll be your homework for tonight, due by the end of the day, Friday, May 1st. And if you have any questions, get with me. Give me a call. We can video if we need to re-explain something. But make sure that you understand everything. Now, we are up against a quiz. Okay, this is quiz number 34. It covers sections 11.1 to 11.4. So we'll probably take this on Tuesday. So for Monday's lesson, I'm going to take some time, just a few minutes, let you know what's going to be on that so that we understand everything that's included in that quiz before we take that. All right, so that will probably take on Tuesday. Again, that's over 11.1 to 11.4. So if you have any questions on those sections, get with me before we take the quiz so we can get those worked out. All right, guys, that's all I have for you today. Have a good day and get that homework to me on time, please, so you can get a good grade for that. And we are moving along here. We really only have 15 more days of 15 more class days left. So after these next few lessons, we'll start reviewing for the final exam and set a date for that. All right, guys, we'll talk to you later. See ya. Bye-bye.